All right, well, welcome to the Introduction to Google Earth Engine for the Geospatial Frontier virtual conference. I'm happy to be joining you. My name is Josh Williams. I'm a high school teacher in the Austin, Texas area, and Adam asked me to just kind of introduce Google Earth Engine for those of you who might have seen it but not have actually kind of dabbled into this powerful resource. If you want to follow me, you can follow me on the Twitter at GETeach. So this is what I have for our agenda for the next 25 minutes or so. It's kind of just the nuts and bolts of what is Earth Engine, and then we're going to create a quick app. And if you look at the link, there's a GitHub. You could just copy and paste that into your code editor once we figure out what that is. And then I'm hoping to show you kind of some apps that I've done for my classroom. So the first off is, what is Google Earth Engine? If you click on the link, it'll actually take you to earthengine.google.com. Most of y'all know that Google Earth Engine is not actually Google Earth. It is a collection of satellite data where you can kind of put in your own real-world algorithms and you create your own real-world applications using Landsat or Sentinel or other data sets that I'll get to in a little bit. The idea is that you're using remote sensing to explore this world with a bunch of ready-to-use data sets with a powerful API. So if you know JavaScript or Python, it's really not that hard. And it even comes with this convenient code editor tool. Once we get into it, you'll see, I think, how easy it is to actually use. I'm going to use JavaScript just because it's, for time reasons, it's going to be a lot easier for us to kind of create a project real quick. And lastly, you actually have to sign up to be part of the solution, actually to be part of Earth Engine. I'm on my account. If I was on one of my other accounts, if I went to Platform and hit Code Editor, it would ask me to register for Earth Engine. It takes a couple of days once you put your application in to get approved. So that's kind of the general what is Earth Engine. I think what most people are interested in is like, well, what data does Google actually have curated for you? So this is a lot of information that's freely available to use for you to create your own application or create your own algorithms to explore the world. And those are just some of the examples. But if you view all data sets, you'll see just how many satellites and sensors that are available to you just to use. And I by no means used all of these, but I do have fun kind of exploring as many as possible. And I've spent many hours kind of down the rabbit hole of satellites and sensors on satellites just to play around. But it does have Landsat data, Sentinel data. Those are kind of the big two that it really has. MODIS as well, sorry. Big three. And then you can just kind of use different bands to kind of explore your world the way you want to explore your world. So that's the data catalog. So again, the way that I got there was I went to just this Earth Engine, and then I clicked this data sets right here. Now, I think a lot of people have seen Google Earth Engine, even though they might not know it was actually Google Earth Engine. Their time lapse is probably their popular product that they've been using. This got redone, I don't know, a couple months ago, actually probably half a year ago, maybe a year ago now, where it'll come in and it'll show you kind of the best pixels over that entire year, kind of moving through time. So you can pause this, and this works really well on both a phone and on a desktop. But this is really where kind of the showcase use case is for this, is kind of a time-lapse video using Landsat. And the way that, again, that it happens is they take all of the images for the year, find more or less, find the best pixel from that year and kind of put it all in there and that pixel is made the year's best pixel of that lat and longitude. So that's probably their product that they use, but you can actually create things like this, similar to this. Maybe not as detailed, but little JavaScript, little Python, you're good to go. So we're going to go get and give it a go, and I'll show you how the easiest way to kind of get quote unquote started. So I'm going to go ahead and go to Sentinel, and then from here you see all the Sentinel sensors that we have. I'm going to Sentinel 2, and then I'm going to go to top of atmosphere here. And whenever you actually drill down to the satellite itself, you have a description. So it'll tell you the description of the satellites. It'll also give you all the bands, because you're going to need to use a combination of these bands for whatever you're kind of looking for in the world. Some of the image properties, so it's meta, and then the terms of use. But what's really cool when you do this is often when you have a satellite, you'll see these functions that are already built in. So this function right here, it's going to mask the clouds, it's going to load the data, it's going to style the data, and it's going to give it a name. So I'm going to go ahead and open this in the code editor. And if I run it, what you're going to see, it's going to move me to that place, and it's going to load the Sentinel images between those time periods. I'll show you just a second once it finishes loading. All right. So that's the script it took to actually load that map. I'll walk us through it here. This masks the clouds, hence the mask clouds. And you look at it, says look at the image and select QA60. And if you look at QA60 in your bands, you see that that's a 60-meter cloud mask. So this variable here, you set the variable data set, get the image from Sentinel-2. That is its collection name. You get that collection name from right here. See where it says EE image collection, right? Copernicus S2. So that loads it, and then you filter it by date. So the date for this image right here are the best pixels in 2018 from January 1st to June 30th. There's a filter on it to kind of help with the clouds a little bit. And then you map it, and then you get this function, right, to kind of put that cloud mask on top of it. Then you have the bands itself. So you have the data that you need. So that's right here, where it says map data layer. It'll load the data, get the median, the middle, and you're going to style it. So the min is 0.0, the max is 0.3 of bands 4, bands 3, and band 2. So if you look at it, band 2 is 10 meter blue, band 3 is 10 meter green, band 4 is 10 meter red, so RGB at 10 meters. And then that's what you get for the image itself. This is the title of it. So this right here, layers, someone came here, it says RGB, where I can click it and unclick it. That's where that got that name from, that title from. So it's really easy to load, as you can see, using their samples, just a cloudless Sentinel image over those dates. So using this, you can actually, with kind of pretty few amounts of lines, create a slider where you're looking change over time at 2 different points of time, maybe for a user. So I'm going to go ahead and do that real quick, and hopefully we can learn something in the process. So what I'm going to first do is I'm going to clear everything out. And this basically just starts me from a new canvas. And what I'm going to do is I'm going to create a slider function. So the left side of the map is going to be October of 2018, and the right side of the map is going to be October of 2019, both Sentinel images. So I need to set a variable of the left map and give it a UI of map. And then I need to set the variable for the right map. So I've just created two variables, one left, one right. And what I'm going to do is put them next to each other, actually on top of each other, and then create a slider. I'm going to leave this all of the same. So I don't need to touch anything where it comes to the function for the cloud map, the clouds, the mask, because I'm going to need that. But instead of one data set, I'm going to need two data sets. So this only covers one range of dates. I need one for two ranges of dates. So I'm going to call this data set just left for right now. Leave everything the same, except for I'm going to change the dates. So 10 of 01 to October 01 of 2018. So right now I have some left variable that's going to get the image collection from those dates. And I'm going to go ahead and just copy that. And then paste that. And then I'm going to have a right map with the exact same month and day, just a different year. And I want to compare the same piece of land at the same time of year, but two different years. That way I have something that's actually comparable. The styling is going to be the same, so both of them are going to use the same min, max, and bands. So that's pretty easy to do. Now I just need to add my layers. So I changed the variable data set, and it's no longer called map. It's now called left map. So I'm going to call this left map, and then this is going to be left. So I'm getting this variable. I'm going to add a layer to it. The layer I'm going to add is going to be this information right here, which is the Sentinel-2 collection of the month of October, using that mask, and then using this styling. And for this, I'm going to say October 2018, because that's going to be its name. Now I'm going to rinse and repeat and do that same thing for the right map. Okay. So right map, because again I made that right map UI right there, and instead of looking for the left data, I'm going to look for the right data, and that right data will give me this collection, but for 2019, October 1st 2019 to November 1st of 2019, and then I'm going to call that October 2019. So that will load two maps, one map which I'm going to have on the left here in a second. I'll show you how to position it soon, and then one map on the right, and I'll show you how to position it again pretty soon. It's going to take the middle. It's going to get of all of those data, of all of that between 2018 of October and to November 1st. Give it the styling. I'm saying styling because I come from a different world. And then October 2018 and October 2019. Now I'm going to set my map center a little bit differently. I'm going to go ahead and move this. I'm going to come back here. I'm going to paste it. And what I'm going to do is I'm just going to left map center, because there is no map right now. Remember, I took it out when I put in these variables. So what I'm going to do is I'm just going to, I can center one or either left or right. I'm just going to do left map because that's the one I'm used to. And then the latitude and longitude that I'm going to use, it always starts with longitude first. So I'm going to use longitude 121.5407387. And then I'm going to use a latitude of 39.7725.371. I got those longitude and latitude points just by looking at Google Maps. It's just easier that way for me. I could add a whole function here and click on it and find the points, but it's not that big of a deal. It's easier for me just to use maps. The zoom level, instead of 12, I'm going to do 11. So that's going to, when I run the program, it's going to load these two maps, and it's going to center the map at 121 degrees west and 39 degrees north at a zoom range of 11. Pretty easy so far. All right, so now all I have to do is make the actual split. Actually, I don't know what it would do if I run this right now. What will happen? All right, nothing. Cool. So now I have to run the split. So then this is pretty easy. And I got this from one of the examples over here, by the way, like the split example. So var split panel equals UI dot split panel and then this will be UI split panel and then function. Cool. And then first panel is going to be left map, and then second panel is going to be right map. And then this will be wipe, because we are going to have a swipe function on this thing, is true. And then we're going to style now. Stretch both. And then close my function off. Cool. So there's my function right there. So it's going to split the panel, UI split panel, and the easiest way to get that is if you go to the documents and then look at UI, and you can say split panel, and it'll show you everything that you need to do. So there's your argument. First panel, second panel, white, true, false, and then any styling. So all of this is found in the docs itself. Right. So we've got our split panel set up, and now we just have to create a UI again, put the widget in, this is what I was trying to do earlier. And then we have to link them. So we're linking the left map with the right map. All right, and then we centered it. So what I typed there was I got the UI splitter there, and then I'm creating a linker. All right, so resetting the widget to a split panel. The linker is going to be left map and right map. Right? And then we should be able to run it. Stretch property. Oops, misspelled it there. There we go. Go ahead and run it. Perfect. It helps when you spell things correctly. So this is the app that we made. So we have on the left side 2018, on the right side 2019 with our split screens and a white. So both in October, and you can see the damage, right? If you know where this place is, I'll go ahead and turn off it. This is Paradise, so California. So that's the campfire and the kind of landscape from the campfire itself. When you zoom in, it's going to retile. So there's 2018. There's Paradise itself, and it's going to load the left map, and then it's going to load the right map. Again, it's actually loading both maps, and just kind of you can see the city. So that was the kind of real quick way to create a split panel. And again, the way that I kind of learned how to do it is you go find an example here, which will get you started with any of the user interfaces. So here's the split panel, for example. And you just kind of get your data, use a user interface, and you can create an app that quickly. Now, the way you save this is because you keep saying that that's a read-only. I'm just going to go ahead and hit Control-Alt, Control-C. And then this is where this is my repositories up here. Yeah, I'm going to abandon those changes. And I'm going to paste it here, so now I can save it into my own repository. And run. So now I have it. These are all the files that I have created up to this point. And then if I want to create an app, just click this app button and put in your credentials, and you can create an app. There are limits, but I find them adequate for everything that I do. So I hope that makes a lot of sense, that this is just a simple script where you're loading these image collections from Sentinel, right? You're getting the clouds taken out of, you're applying the red, green, blue bands to it, and then you're creating a simple split screen. And then you load the widget or the split panel using the left map and the right map, right? The layers that you added here and here. So that's the simple JavaScript of it. If you are interested in just copying that JavaScript and kind of playing around, it's right here in the GitHub, already put together for you. Feel free to just take it, manipulate it, do whatever you want with it. So that's in the presentation itself. Some projects that I've used for the classroom to create this using Earth Engine. Is once you create the apps, you can put them in a simple iframe. And this is 60 years of climate data. And this is the monthly temperature, and here's the monthly precipitation for that year. So if I click anywhere, it's going to go ahead and find the data for that place, be it the temperature of 2018 or the precipitation for the month. And you just change it using this panel instead of the split screen is the same kind of thing. It's a different UI. There's also precipitation in here. So 60 years of precipitation. And oddly enough, there's also sea surface temperature, but I don't remember how long. Let me see here, because I always cite everything. Up to from 1981 on. So there's sea surface temperature as well. I can't remember why I put elevation in here. Maybe it had something to do with, I do know why. It has something to do with our curriculum and the impact of elevation on climates and rain. So a good example for this one is I'm going to hold down the control key so I can zoom in here. And I'm going to go ahead and just turn off the elevation and just show the precipitation. And then if you look up right here in Central America, we'll look at a La Nina year, for example, in 1999. And then we'll look at an El Nino year, right? So you can see the precipitation changes that occur. There's not as much precipitation in that part. In a La Nina, there's a lot more. And an El Nino, and there's a lot more in a La Nina. So that's how I would use it kind of in the classroom. I could even put my little marker there, and it'll generate the temperature and the precipitation patterns. So that's one thing, that 60 years of climate data. But I actually teach mostly a human geography class. So you can also do some of the layers that are in there is for population. So this is that split screen that I showed you. So this is global population of 2000 and 2019. And this just happens to be Austin. You can see, because that's, as you move it around, the split screen, you can see how many more people are moving into Austin. And if you click on a polygon, if you click on the image, you'll see that it changed the population for in that 100 by 100 grid wherever I'm clicking at. So found some farmland in Texas, right? But in this one, where I just clicked, it's 64 people versus 105 people in that 19-year time period. So that's pretty cool. And again, it's global, so you can do split screens and look around. Another one that I was working on was this city accessibility. And this was really cool. So this is how many minutes that it takes for you to get to a town. So I'm going to go ahead and hit Control, kind of zoom into the Austin area again. And I'm going to put 5 minutes and update the map. So that's how clustered people are. Those clusters there are how many people can get to town within 5 minutes. And if you change it to something as like 60 minutes, so what about an hour? And you can start seeing all of these metro areas reaching out and touching each other. And it's really cool, especially since we were in our current state, I guess, looking at diffusion of different, in this case, vectors. You can kind of see the transmission or how close we really are together. But that was a pretty cool data set from the Malaria Atlas project at the University of Oxford. So it's down here. That's where I put everything. And then lastly, I know I'm not the only one who's done this. Plenty of people have done this before. As far as looking at like COVID and nitrous oxide. And a lot of the papers or websites I saw, they were interesting. I guess I started this one, I don't know, before spring break, maybe at spring break, so way back in March. I tried to update it, and I put it in 2-week intervals because it seems like there is a lag of 2 weeks, an unfortunate lag of 2 weeks from exposure to when things get really bad. So that's kind of the same idea at a global scale. But what you can see here is that this is January 15th. If I go ahead and turn this to, let's just say February, it's going to reload. And a lot of people have made a suggestion. It's like, oh, when people stay home, that there's less pollution. And there very much is when people stay home. So this is January 15th through January 31st, looking at the average near Shanghai. You can see there's quite a difference. But when I move this back to April 1st through April 15th, and I'll go ahead and change this to February 1st through February 15th, when China was under a pretty serious lockdown. That lull, and I think a lot of climate scientists are making this argument, I hope they are, that it didn't last. Right? I mean, once the city came back online, the pollution came right back. But hey, it was an interesting experiment. You can click on this as well, anywhere on this map, by the way, and you'll see the daily rundown. So the blue is the 2019, and then the red is the 2020 data set for NO2 by day. You can click anywhere on the map, and it'll generate a new line graph for you. Just take those 74, 75 days or whatever, and generate the same line graph for you. Sometimes it takes a little while to do all the math, but it's really cool, really interesting. I was looking forward to showing this to my students once I got back, but we are not making it back this year. So there's the lines. So there's 2019, the blue, and then the red. You can see it's starting to rise again. All right. So everything that I've talked about or spoken about is here. So we went over what is Google Earth Engine. We looked at some of the data sets. We quickly scripted an application. I hope you're able to follow along. If not, just go ahead and feel free to go to that GitHub and grab it and read it. And then showed you some examples that I created for my own classroom here in Austin, Texas. I hope this was useful. I hope you enjoyed it. I hope you got to learn something new. Please feel free to reach out. My Twitter handle is @GETeach. That's probably the easiest way to get a hold of me. If you're interested in Earth Engine, there's the hashtag Earth Engine. If you follow that on Twitter, there's just a pretty sizable community that does a tremendous amount of science and work and models and predictions based off of all of this remote sensing raster data. I hope you enjoyed it. Feel free to reach out and enjoy the conference.